I'd like to share with you a key set of guidelines for designing IoT-based products, applications, and also to think about design. I mean, how you really think about developing an end-to-end system. I wish to first share with you the motivation of me getting into embedded systems. So when I was in my freshman year at college, I got a chance to be invited at MIT under the guidance of Mr. Walter Bender, who was the executive director of MIT Media Labs. And he gave me the chance to bring the cost of laptop down from 1,000 US dollars to $100. When I was a student in way back in 2004, the cost of laptop used to be $1,000, and $1 was at that point 45 rupees. Now it is a different price point. And my objective was how we can cut down the cost of laptop down so that every student in this world can have an access to a digital device to access the internet, to really utilize the digital medium for education. So I joined an organization under his guidance, namely One Laptop Per Child. That was the name of the project. And the whole idea of the project was how we can get one laptop to every student in every part of the world. I mean, who would not have access to the internet, but would have an access to the laptop for learning, and how we can do communication without the internet and with the internet wherever it is possible, and mesh-based networking where internet is not possible, so that everyone can have access to all the digital content which is available for learning. So that was my motivation way back in 2004, 2005. And I joined this particular organization, and I was responsible for bringing the cost of laptop down from $1,000 to $200 and $150. So $100 price point we achieved in a matter of 4 to 5 years. But the whole idea and the whole journey, it gave me the notion that how embedded systems and how so a laptop at the end of the day is an embedded device. So how we can build up devices which will enable us to transform our generation and the generation next. So that was one aspect. The second is that we know that there's a lot of e-waste all around us. We know that there's a lot of devices which are actually harming the environment day in and day out. My second motivation was how we can make devices reconfigurable, reusable, adaptable, and also extendable. So that was the second motivation of me getting in the whole embedded systems in the IoT area. And I would, I mean, after working with this organization for multiple years, I got a chance to collaborate with Apple, later on with Amazon, Google, Samsung, and also Barnes and Nobles to work on IoT-based projects which run on their different devices, which is both post-PC devices as well as PC devices. So this is what I'll be interested in sharing with you. I mean, the key practices or the key takeaways of this particular session will be to get you in the thinking mode, in the problem solving mode, on how you can design an embedded system. What are the guidelines which are needed for leaf node design? What are the key applications that in India will be very helpful for you to kind of address when you become an embedded systems designer? I'll very quickly share with you some of the social applications very quickly, because a lot of you would be interested in social enterprise. So some of the applications that I personally feel is water management, which is a very key area in India that could be addressed with embedded systems. The second application that we could look into is all kinds of healthcare applications, like monitoring a patient's heart, I mean, biochip transponders on farm animals, and then also automobile applications. I would also be sharing with you drone management applications. I mean, how you can do drone based design and drone based monitoring using IoT and embedded systems. Then also road safety applications. We know that a lot of Indian citizens, they die due to road accidents and road mishaps. So how we can use embedded systems for road safety and incident management, I mean, that's a very key application that we'll be looking into. And also, since all of you are in college right now, we will look into an aspect that in all these high school years, you would have learned physics by solving numericals, how we can use embedded systems to build up simple, playful balls, IoT balls, I call them, using which, I mean, we can learn Newton's laws of physics, and we can do a whole variety of things. So I'll be taking a lot of case studies today. I'll be getting you in that fun mode of really enjoying and addressing this whole world of embedded and IoT ecosystem. So what exactly are we talking about when we're talking about the things, which is the Internet of the Things? So it is two aspects. One is data collection, second is data communication, and third is an application which needs to be there for addressing the concept that we are trying to solve. So we have communication and cooperation, we have addressability, we have identification, we have sensing, we have actuation, we have information processing, localization and interfaces. Now, a lot of you will say that why localization is important. I mean, localization is the key fundamental for really understanding how different people, I mean, with different backgrounds, can collaborate with each other to solve problems of sustainability, of you can say industrial IoT, and even they can look into aspects like simple things like water management they can do at their home, or they can solve consumer devices problems. So all these things, these are the key technologies or the key parameters that we have to look into when working on an IoT application. The next thing is, what are some of the applications that you would look into? As I already shared that, I already mentioned that we'll be covering some of these applications in the webinar today. There are other applications also. At home, you can do home automation using IoT. You can also do, so right now, you know that there's a current pandemic which is going on. And in fact, a lot of people have breathlessness issues, and they have all kinds of, you can say, air quality issues. So we can definitely develop a pulse oximeter, an oximeter which is used for tracking down your oxygen levels. That's actually an IoT application device. I mean, that's an embedded system which you can even integrate with a mobile phone to give you the alarms. And so basically, if you make an alarm clock application which runs on your phone and integrate that with an oximeter, that is an example of an IoT application. There is one more application which I feel all of you will be aware of. So you are all wearing some kind of mask, right? I mean, air quality masks are right now needed, and N95 masks are also being used. So if you integrate that with a sensor and you have a mobile phone at the other end, which lets you, which gives you an understanding of whether you are inhaling oxygen correctly, or whether you are taking the appropriate oxygen level, even that is a wonderful application of an IoT. Then if you're growing trees in your garden and you would like to have the water monitoring done over there, or the irrigation monitoring, and all kinds of pest rodent monitoring. So all those things are key applications of IoT in agriculture. I mean, you can also have energy management done using IoT. I mean, if you have, say, for example, solar panels on your roof, and you would like to see how the electricity is getting stored at the receptor, and how you are managing the energy storage devices at your home. So that is also an application of IoT. I mean, you can also look into one more key aspect, which is that if you wish to cut down the electricity cost at home, I mean, if you have running air conditioners at home and you would like to cut down the electricity cost by doing monitoring and by utilizing them when they're needed, and also utilizing them effectively. So you can build up an IoT device for doing the same. And similarly, I mean, if you have elderly at home and you would like them to be given some kind of intervention using either robotic methods or even manual method, so you can use an IoT based application on your mobile phone with an appropriate device and sensors. So these are like some of the applications that we'll be covering today. I mean, there are a lot of other applications. I'll be sharing with you around 7 websites, which I have personally worked on, where I've laid down all the guidelines, architecture of the IoT applications that I have personally developed. So the next thing is, what are the barriers to adoption in IoT ecosystem? I think definitely one is the privacy aspect. You would not like your data to be shared on the cloud just like that. There has to be anonymization and authorization that needs to be there. The second aspect is the security aspect. So the security aspect is, what kind of data encryption methods should we adopt that are global standards, which also lead to security and interoperability. So that's the second aspect. The third is autonomy and control. I mean, once I get the device, I would like to be a hacker. By hacker, I don't mean to be a cracker. That means I would not like to break the device, but I would like to utilize it effectively in an optimal way. So that kind of autonomy and control you are looking at. Then there's a social control. I mean, social control basically means that you would not like your device to be sharing data with everyone and anyone just like that. I mean, you would like to share data only when it is needed, and that too in the right way. I mean, you would like some level of autonomy, and you would like some social measurement that, okay, when sharing is needed, it should be shared. When the sharing is not needed, it should not be shared. And also further, that the sharing depends on to what extent you would like to make it social and to what extent you would like to keep it personal. So that is one key aspect at the adoption front that needs to be there. Then there's political manipulation. I mean, we have already seen a lot of elections, both in the West and in the East, getting rigged by data collection and data surveillance methods. So we would like that IoT devices should prevent that. And we have already seen that there are a lot of state-sponsored organizations which are full-time in doing all kinds of hacking in all these IoT devices. So all those things need to be prevented. The other is the design aspect. The design aspect is very, very important because a lot of IoT devices can always be taken to the next level. I mean, we know that the current industry is designed in a way that they expect that you keep buying devices. Like a lot of you would be changing mobile devices. In some people will change that in years. Some people will change that even in some months. But the point is that all these mobile phones that you have, you can be hackers in that. You can evolve them in modular way, and you can take them to the next level without buying new phones all the time. So in the same way, I mean, if you're looking at design of embedded systems, once you buy a certain device, you would be interested in buying more modular components. You would not be interested in continuously buying newer and newer components without them really solving the purpose. So the design has to be modular, it has to be extensible, it has to be reusable, it has to be reconfigurable, also adaptable and repurposable. I'll give you a very interesting idea. I mean, I worked on some projects with Harvard University way back in 2007, and I wish to share with you that the implications, I found that in 2017. So the point is that sometimes the implications and the outcome of a project, it takes considerable time. And that's where the design aspect is one of the key aspects when you are going about doing a development. Also, there is a massive open source movement currently. I mean, a lot of you would be using GitHub, Bitbucket, GitLab, and other ecosystems. And what I wish to share with you that you can search for open hardware innovation. You can check out self-quantize innovation. So all these innovations are surrounded by the fact. So self-quantize movement is around how we can make do-it-yourself devices, how we can make things more do-it-yourself. Instead of having some organizations give you all the devices, so how you can take components off the shelf and how you can make your life do-it-yourself. So those kind of design aspects have to be think through. And those, if you look into those key aspects when you're designing an ecosystem or designing an embedded systems for that matter, I mean, you will end up with a solution which makes more sense. Then finally, I mean, you have to look into the environmental aspect and environmental impact. And we already know that a lot of our activities have been disturbing both the oceans and the land. And the way we are disturbing it is is very profound. And we know that in the next 10, 20 years, if we don't take things in order, I mean, it will go in out of control. And there are solutions for that. I mean, what we have, if you're using plastics, if you're using electrical components, so we can make them reusable. Even the LEDs that we're using at home, we can make them reusable. Now, the point is, how do we go about that? So I'll be covering some aspects of that in today's discussion. And then finally, I mean, how we can have the human moral decision making getting influenced by our devices. I mean, we know that a lot of people are spending full time, and most of the political organizations as well as business organizations, they have a full-time working IT cell, which is using social media to impact us in a very critical way. Now, the point is there's no getting away from all of that. But what we can do is we can muster some kind of thinking and some kind of decision making unilaterally so that we utilize it in a way such that we respect the environment, we respect our homes, and we also enable our utilization of that particular device in a critical way. So we'll be covering some aspects of that too with some applications. Next, I'll move on to some case studies which will get you excited about how these devices are impacting. I mean, how these technologies are impacting worldwide. Because what I wish to share with you is that when you design an embedded system, you should think local, but market global. And you can go in the different lines also. I mean, you can think local and design local and market local as well. But when you look into development, I mean, you can always make things interoperable. And you can all, since we are working on a whole set of mobile standards, so whatever you design, I mean, you can design it for the world. So, I mean, you can have a lot of human tasks getting automated with IoT, and you can have a lot of accuracy in voice and video recognition. You can improve image recognition accuracy. You can do, you can make your life paperless in one way. So I'll give you one example. Like when I was again working with the government, both center and state, what I found is that one of the key problems is that for every single thing, they have a paper, and they just keep giving you all kinds of papers related to tenders, related to contracts, related to payments, related to logs. Now, all these things can be made paperless. You can make all of these things go paperless by utilizing embedded devices and IoT. And I'll be sharing with you with all of you 1,200 applications which I worked on Apple devices, on Google, Amazon, and also your Samsung devices, on how we made institutions paperless. I mean, we have been able to do it internationally. Unfortunately, I mean, I've been in India, but lately, and what I found is that in India, it's the hardest to make things paperless. So I would like to have some questions around that front, and I would love to discuss on how we can make things paperless going forward. Surely, I mean, the current pandemic has helped in making things paperless, but there are better ways of making the institutions paperless. And finally, I mean, we'll be discussing on the value that you can create in the enterprise using these embedded systems and IoT technologies. Finally, I mean, I'd like to share with you what we are finding when IoT solutions are getting deployed. What is the impact that we are observing? So we are finding an increase in revenue. I mean, 30% is, you can say, an average increase, but it can be better than that. Then we have a lot of payments. So all of you would be using, all of you might have used a subway system, and you use tokens or cards, smart cards as they are being called. But what I wish to share with you is that at their backbone, they are nothing but RFID and NFC cards. NFC means near field communication. So I'll be discussing that in the discussion today. I mean, how you think about developing these kind of systems through which you can do real-time automation, and you don't need manual intervention for doing things like payments, for doing things like managing tokens, and also for authorization and authentication. So 94% of payments have auto-matched, I mean, they can be auto-matched to invoices. And here you can bring big data and machine learning. Don't get confused with all these jargons like machine learning, blockchain, and others. What I wish to share with you is how you can use statistical learning to make things better for the end user. And finally, I mean, how you can reduce the maintenance cost. I mean, there is a 60% reduction in the maintenance cost. So how you can do that maintenance cost reduction, and we'll be covering on that. And finally, I mean, better worker safety. Along with better worker safety, I also wish to share with you, we can have an impact on environmental safety aspect as well. And what it needs is some level of thinking in terms of design, in terms of, you can say, deployment innovation, and also on how it is integrated with the other APIs which are over there. So we'll be discussing on that aspect. Finally, we have, I mean, how you can power the smart enterprise with a set of technologies for every enterprise process. So we'll be working on that. As I mentioned earlier, that I would like you, when you work with an IoT or an embedded device, I would like you to think on the extension aspect. Like, for example, if you're using an Android phone, how you can make it communicate with your television, with your fridge, with your bags, with even your shoes. In fact, I wish to share with you, I got a chance lately to collaborate with an organization named Fitwings. And what they were doing is they were developing yarns, they were developing shoes and socks through which, I mean, we can reduce or we can monitor the blood pressure of a particular person. And also we can use sensors for managing the blood sugar levels. So it was like you can say not a competitor to glucometer, but something which we could use along with glucometers. And also, I mean, it was used for managing all kinds of ailments that we have around our feet. So the thing is that when you think about innovation, about solving a problem, so you can definitely think about extension, you can think about optimization, and you can also look into one very key aspect, which is around transformation. So when you look into these things, I mean, it will enable you to think about industry innovation kits. It will enable you to think about embedded intelligence, and finally, open innovation. So open innovation is like innovation around you, around your environment, around the enterprise and organization that you work in, around cities. So a lot of smart cities can be built in using a whole sort of IoT solutions. The whole idea is to make it cost effective also. It's not like, I mean, if you have to solve a problem. So a very good analogy, which I do share with most of the people, I mean, who attend my webinars or who attend my sessions, is that, I mean, a system where they use a gun to kill a mosquito. The point is that you can definitely kill a mosquito with a mosquito mat, and that's the right route for that. Now, when you're designing a system, go ahead and think in that order, that you have to make things cost effective. If you're making a laptop, so you can definitely look into systems through which you can make it optimal. I mean, you should definitely adopt a strategy where you are using a mosquito mat to kill a mosquito and not a gun to kill a mosquito. So think on those fronts. I mean, think on those fronts. You have to definitely be a person, I mean, who is at the end of the day trying to be optimal and trying to be clear in their strategy of development. So it should be design led innovation. It should be a solution ideation and vision. There should be rapid prototyping. And finally, you could have an integration blueprint, and finally, a business case development. So that's the structure of open innovation in IoT. Some of the key jargons that you will come across, but you don't have to worry about them, is machine learning, blockchain, data intelligence, Internet of Things, and analytics. We'll cover them one by one on how you can access resources. GitHub is a very profound resource in an open access way. There are others as well. So we'll discuss about that. In terms of the cloud platform that you would like to use in case if you wish to make things cloud oriented, is that you could use concepts like microservices, open APIs. You could have flexible runtimes. You could do integration with systems like EtherCalc. I would like you to search for EtherCalc on the internet. It's a very interesting open source spreadsheet. You can get the source code of EtherCalc in a very easy way. And also check out Ionic App Platform. So by Ionic App Platform, you can make things cross-platform, and whatever you develop, you can have it available for Android as well as for iPhone, as well as your television, your computer, your tablets, all kinds of devices in one single go. So I would like you to check out both these systems. They are very good systems for integration. I mean, there are other methods also. There's something called as ST-modes. ST-modes is something which is used for indoor navigation in a lot of places. And it is something which, like a very good example of it, you can check this out. This was in fact done by one of my friend at IIT Delhi. What he did, interestingly, he came up with a smart cane for blind kids. And the smart cane, what it does is that it figures out obstacles by using a method of sensors and by using radio wave emission. And it gives you some kind of an outcome or a feedback in your hand whenever there's an obstacle in the vicinity. So there are some very interesting integration systems that you can adopt over here. You can also have data management suite. So data management suite could be around cloud, it could be around data hub, it could be around EA designer services. You could have multi-cloud infrastructure. I mean, these are some of the infrastructure which are available in proprietary. There are some others in open source as well, namely OpenStack. You can check out OpenStack. I would not have mentioned it over here because these are some easy methods to get you started, but you can also check out OpenStack. So OpenStack is a very key one. You can also check out CloudStack. You can check out Joint. So these are like some of the infrastructure solutions that you can check out. Finally, I mean, there's some interesting examples of doing you can say IoT-based deployments in your city as well. So wherever there is a shop or wherever there's a series of stores, you can always improve the point of sale systems using IoT-based devices. So you can have an IoT-based device through which you can use a whole set of systems. So you can have an invoicing application on your phone or on your tablet. And on the device front, like on the other front, what you could essentially have is a point of sale system which talks to you internally. And you could do that communication either using Bluetooth or using Wi-Fi or using NFC. So I'll be sharing how you do using all these three systems. The next is that, I mean, as I mentioned to you that when you make things in this particular order, the way I explained, like you can have an optimization, you can have an extension, you can have a transformation. So you will cover all these aspects. You would have an app on the user front. For extension, you will have a device. And on the transformation front, you would integrate it over the cloud. So when you go in that particular order, you will have an end-to-end system. Like for example, for oximeter, you could have an oximeter device. So you could use the principles of analog and digital communication for making an oximeter. On the other front, you would have an IoT modular gateway. So what is IoT modular gateway? It's a simple gateway solution which will enable you to talk to your phone that you have. Once you commission that, once you authorize and authenticate the device to talk to the particular solution. So what you will do is you will take up your phone, you will basically put, you will authorize it and authenticate it using Bluetooth, Wi-Fi or NFC. NFC is like your token card whenever you go to a metro gate. So on an AFC gate, you basically put up your smart card or a metro token and the gate opens up. So in the similar way, you would basically use your mobile phone once to commission that on the end node. And then when you basically start using it, the oximeter will start sharing with you readings directly using the Wi-Fi module or the Bluetooth module or the NFC module directly to your phone on how you're breathing currently. So if someone has a COVID-19 problem currently, or even if someone is having a breathlessness problem, so they can use that kind of a solution to do an end-to-end monitoring. Same thing with blood pressure also. So for a blood pressure, I mean, there are two kinds of blood pressures. One is a systolic blood pressure, and the other is a systolic one. So when you have these two particular measurements, so you can do those measurements using your sock sensors, using your shoe sensors, and you can essentially integrate that with a particular mobile application. In fact, I've made one application. I'll share with you that application. It's an IoT application by the name Blood Pressure Register. You can find that both on the Android store and as well as on the iPhone store. It has been there for the last 10 years almost. I wouldn't say 10 years, 8 years since production. And this particular application, it lets you do blood pressure monitoring in real time.